So good morning to all the students. In this proficiency module, we are going to discuss on the topic called data to information. I want to talk to you about a fundamental aspect of our modern world, the data, and how it is transformed into the valuable resource we call information. In this digital age, data is the lifeblood of our society, powering everything from scientific research to business decisions. It is not just a buzzword, it is the key to understanding, predicting, and shaping our future. And thus, in this digital age, understanding how data transforms into valuable information is crucial for success in various domains. So, it is not only important for streams like data science or artificial intelligence and machine learning. It is related to each and every stream of, whether it is automobile students or it is electrical students or ECE students. Each of us need to know about data and how we can extract information out of that data. But what is data? From the moment we wake up and check our smartphones to the endless stream of information that flood our inboxes and social media feeds, data surrounds us. Whether it is the weather forecast, our fitness tracker data, or our online shopping history, we are continuously generating and interacting with data. Data is the raw, unprocessed fact and figures that we gather from various sources, be it sensor, some surveys, social media, emails, or countless other channels. It is generally characterized by sheer volume, velocity, and variety. But whenever we hear the term data, then some digits, some numbers come into our mind. Numbers like 0, 1, 2, 3, etc. And we call this data driven world. But please understand, data is not limited by numbers only. It can be some text, some images, photos, videos, anything can be data. Data is something that can be stored digitally and from which we can extract some information. That is data. Then what is meant by information? As I have said, that information must be extracted from the data. Information is actually the answer to some specific questions. And that answers lie hidden within the data. We need to analyze the data to get our answers back. And that is information. Let me give you an example to clarify. All of you spend a lot of time on internet from morning to dawn to dusk to night. You are always searching different topics in Google's. You are writing mails to your friends. You are chatting with your friends in WhatsApp, Telegram, Facebook, whatnot. You are posting comments. You are posting videos, reels, etc. Say on a particular day, you have spent 10 hours in internet, and out of that 10 hours, you have spent few minutes, only a few minutes, in searching of a particular type of pen drive in say Google search engine. And after some hours, when you open your Facebook account, to your astonishment, you observe that some advertisement from Amazon are showing the same type of pen drive that you are looking for. Isn't it amazing? What is actually done here? Not only you, lot of people are sharing their information. They are sharing a huge amount of data and the company like Amazon, Flipkart, etc., they are just extracting the required information that they require. And what is that information? The answer to a particular question. Question is, do you require a particular uh, item that is available? Do you require a particular item that is available in Flipkart? If it is so, then that item will be shown to you in different social media. This is called target marketing. This is a good example of how the required information can be taken from the available data. I'm giving you another example. Suppose you are a restaurant owner and opened a new restaurant at a particular part of the city. After 1 month of the opening of the restaurant, you want to know whether your restaurant is liked by the local people. So you have a specific question in mind. Do the people like my restaurant? Either the answer is yes or no. So it's a particular type of classification problem. If time permits, remind me, I'll discuss about what is meant by this classification or regression problems. So that is different issue. But the point is, there is a particular question. And how the answer can be obtained? So as restaurant owner, you hire some data analytics group, and what the group does, they take some survey, they talk to local people, they give some questionnaire to have the answers, they have to have the feedbacks of the local people. This is one way. They will look for different comments, different posts in different social media. Say some people have posted some photos in Insta, some other have commented on that photo, and the photo is related to some food in your restaurant, or some are writing about whether it is a good thing or bad thing, that's different. But people are writing on your restaurant, and some others are commenting on it. Some are posting videos related to your restaurant. So the data analytics group collect everything related to your restaurant, and then they try to analyze that raw data to find one answer, whether the local people are liking your restaurant or not. So it is the answer to the specific question, and that is information. Once the answer is obtained, that means after analyzing the data, when the group gets the answer, suppose the answer is that people are not liking your restaurant, you get the information, and information gives you the knowledge. And once you have the knowledge, you can further proceed with it. Like in your case, if you know that your restaurant is not liked by the local people, there must be some reason behind it. So your next attempt is to find out why the rating of the restaurant is poor, why the people are not liking your restaurant. Now, question is completely different. In the previous case, question was a completely categorical question, whether people are liking or not, yes or no, whether your email, the email you are getting is spam email or it's a normal regular email. So it's a classification type problem. You need to classify between two groups. Now, in the second case, the question is completely different, because the rating of a restaurant depends on several other aspects. Like there are several attributes on which the rating of a restaurant depends. Like what is the position or locality of the restaurant, what are the types of foods served in the restaurant, what are the quality of the foods, what is the ambience, what is the service. So there are several attributes on which the rating of the restaurant depends on. So now the data analytics group does the same thing. That means they again collect data from different sources, and they analyze that raw data to extract the answer to that question. That is information. Suppose after thorough analysis, it is observed that it is the service that makes the rating poor. So once you know the answer, you know the information, you get the information, then you can utilize it. As for example, if you know that the service in the restaurant is poor, then you can rectify it. You can make the service a little better. So this is what data and information. So there is a complete understanding of, there is a complete relation between these two. Now, as I have said, data can be anything that can be digitally stored, and by analyzing which you can extract your required information. So broadly speaking, we can classify data into two types: structured data and unstructured data. Structured data means the data that can be displayed in a tabular form. Matlab, we can make a table. There will be some rows in the table, there will be some columns in the table. Generally, and in fact, you have used spreadsheet, Google Sheet, Excel. These are example of tabular forms. In fact, in your school days, you have made also some tables for your experimental result, to show your experimental results. So those are tabulated form, and the data that can be fitted in that tabulated form are called structured data. So generally, numbers, dates, strings, characters can be placed in that way. Characters means say A, B, C, D, M for male, F for female, etc. Strings means say your name, your place of birth, name of your school. So there are some strings. Those can be fitted in those tables, and those data are called structured data. You understand, they use minimum amount of storage, and it is the structured data very easy to analyze. Analysis is very important because whenever you want to get the information, whenever you want to find out answer to certain questions, you need to analyze the data, and that's where structured data are very handy. But unfortunately, most of our available data is unstructured. Like whenever you send emails, whenever you post some comments, post some reels, videos, images, these are unstructured data. They cannot be fitted in a tabular form. Their size is heavy. They take huge amount of storage. But these are unstructured data. And hopefully you understand, it's very difficult to analyze unstructured data. Generally, what is done? Those unstructured data is converted into structured form, and then only they are analyzed. Let's give an example of structured data. So we observe there is a table with 4 rows. You observe there are 4 rows here, and there are 4 columns, 4 attributes also. Each row says about some students. These are different students. The name of the students are written here, and different attributes corresponding to each student are given in those columns. Like what is the gender of that student, what is the place of birth, what is the number of siblings the person has, what is the height, etc. In fact, I can add more and more attributes, more and more columns to it. As an example, if I just add another column, say date of birth, that will be another attribute. So this is an example of structured data use. Now, here you observe the first 2 types first two types deals with character or strings. The gender, either M or F is written. So these are characters. Place of birth, Howrah, Patna, Kolkata, etc. is written. So that is, there are some strings. So this is one type of data. On the other hand, the last two columns tells us about numerical data. So these are example of numerical data. These are numerical data. So we can broadly classify again structured data into two types: categorical data or qualitative data. So these two, gender and place of birth, while we are using characters or strings, are generally called categorical data. On the other hand, in most of your cases as aspiring engineers, or when you become engineers also, you will mostly deal with numerical data or quantitative data. So these last two columns are example of numerical data. And numerical data can be of two types. The first one, where we will have a particular uh, type of data, we call them as discrete data. You observe number of siblings may have zero, there's no number, no siblings. The person as I like Orithro has no siblings, brother or sister. But Jhinuk has one, Kaurav has three. So number of siblings can be 0, 1, 2, 3, 4, 5, etc. It cannot be in fraction. Like I have 3.2 number of siblings, completely meaningless. When we are talking about number of rooms, I cannot say 3.2 number of rooms. Either it will be 3 rooms, 2 rooms, 4 rooms. So they are discrete numbers. On the other hand, there is another type where the data can be changed continuously, and we call them as continuous data, like height. You know, height of the person, say, cannot be less than, in general, cannot be less than, say, 100 centimeter, and generally is not greater than 300 centimeters. So there is a range between 100 to 300 centimeter. Anything can happen. So one person may have a height of, say, 164.5 centimeter. Another person may have 164.392 centimeter. There is no restriction. If my measuring device is accurate enough, I can have any number of digits after decimal place. So there is no restriction how the numbers will be chosen. So these are called continuous type of data. Now I'm unmuting all the students. So if students have any query, they can ask me. So if you have any query up to this, don't hesitate in asking me.
So can you
Sir,
please
can you show
explain
the
nominal and
difference?
ordinal?
Can I show the? Cannot
Sir,
hear
can
you.
you show the difference between structured and unstructured data?
Structured and unstructured data. Structured data. Structured data means the data that can be put in table form. Like the example is given here. Here, the name of a person. I can put the name of a person. I can write the name of a person like this. I can put the place of birth like this. I can put the weight or height of the person in this way. So that can be placed in a table. That is structured data in simple terms. Or on the other hand, in layman's language, suppose you have written a comment or you have posted something on your some text. You have posted some text in Facebook. How can you place it in the table? Or you have placed image of a person, image of a landscape picture you have posted. How can you fit it in the table form? So those things which I cannot show in the tabular form, generally generally a large amount of text, like emails, comments, likes, dislikes, smileys, emojis, videos, photos. These are generally unstructured data. Simple terms, if I cannot place it within my table, this is unstructured.
Sir, can you please tell me about the difference between nominal data and ordinal data?
Okay, nominal data. As I have said that categorical data means this type of data where either we're using some characters like this or some strings like Orithrobosh. This is a string. Haora. These are some strings. Then these are called categorical or qualitative data where I cannot quantify with value. There's no value associated, right? So in those cases, I we have to use categorical data, and categorical data can be classified into two types. General type this is the general type of data where I'm writing the place of birth as Howrah, Patna, Kolkata, Bardhaman, etc., etc. There is no order here that Calcutta should come before Bardhaman or Patna should come before Kolkata. There is no order. Whereas in some cases, order is important. Like say your marks in different subjects. Say your marks in maths. Different students are getting different marks in mathematics, and that is denoted by different uh, uh, data say, different characters say. We are using say in the math exam, someone is getting B, someone is getting E, some A, some O, etc., etc. So these are different digits associated with the marks of the person, right? Etc. So these digits, these characters are, of course, they are categorical data, but they are ordinal data also because there is a particular order that is followed here. What is that order? We know that if the person has marks above 90, he is regarded as outstanding marks. So it is best marks, O. Then if the person has marks between 80 to 90, then it is denoted as E. Between 70 to 80, A. And so up to the failure F. So here, order is the vital. So this is called ordinal data. So when there is a relation between among those data, there is an order in the data, then we call that ordinal data. But as I said earlier, our discussion will be confined into only numerical data because that is the type of data most of you will deal with. Anything else?
Yes, sir. Sir,
Hmm.
sir, good morning, sir. I have a question not related to the data, but I have one quietly related to the calculator. What type of scientific calculator we will be using? Can you please help me with this information?
What type of scientific calculator you will use? This also be discussed in a proficiency module. So stay tuned.
Okay, sir. Thank you,
Probably
sir.
tomorrow, Mujambil Rahman sir will take your class on proficiency module and he will elaborately discuss on this topic,
Thank you,
especially
sir.
calculator and how to use it.
Uh, Hello, sir. Good morning, sir.
Morning.
Sir, I want to ask about the target marketing which you said. Like there are already millions of people or lakhs of people would be searching about the same thing or different thing. How can we target that particular thing about, you know?
Okay. The point is that, as I have said earlier, what is the intention? Intention is that, say, Amazon. Amazon knows what are the products that are specified in their category. In Amazon, when you search a product, you will get some products, you may not get some other products. So Amazon has a particular type of categories that are available in Amazon list. And they search a huge amount of data. As I've said earlier, it's huge. Terabytes of data are generated per second. And that huge amount of data is analyzed. You think that huge amount of data is analyzed to find out whether the items that are specified in their category are searched by people or not. And I understand your problem that you are thinking there's so much data available and how to extract a simple short information out
sir.
of it.
Yes,
The
sir.
different processes uh, is just the beginning of your journey. So with time, you will learn several methodology, you will learn several uh, skills, you develop some skills to understand this. So we'll do it one by one.
Thank you,
Sir,
sir.
good morning, sir.
Hmm.
Sir, I have a one question. Hello, can you hear me, sir? Hello,
You're not audible, correct?
hello,
Hmm.
hello, sir. Can you reach me? Hello, sir. I'm Ronit Sarkar.
I cannot understand your query.
Sir, my question is the main difference between the discrete data and continuous data that can vary. I think continuous data can be continuously varies. Just like we take many variables in X, Y, and Z. This can be variable. So discrete data can never be vary, and continuous data can be vary can anytime. That is not
Both,
not that.
both can be varied. Like number of siblings can be varied, but there are particular numbers from which you have to choose it. Like number of siblings can be say 0, 1, 2, 3, 4, 5, 6, up to max 10. So you have to
Yeah.
choose the number out of that 11 numbers from 0 to 10. Whereas you think height. Height is, you cannot constrain height, you cannot restrict the value of height. Between a range, it can be anything. Suppose my own height, I'm measuring with a normal scale, I'll get a value. If I use a better device, I'll discuss it today. Or if I use a better device, more accurate device, the value will be changed. But number of siblings cannot be. Whatever, how you're measuring it doesn't affect it.
And
So
sir,
continuous data means when there is no constraint about that data.
sir, I have so one question more. Sir, I think discrete data. I mean, as an example, number of siblings you have said it can be integer, but continuous data it may or may not be integer. Can we say that?
Right, very good. Right. It can be integer or it can be fraction, right?
Then we can say that numerical or quantitative data may or may not be integer or non-integer, but discrete data, that means number of siblings will be always integer in number.
No, may not be. May not be. Good query. Good question. The first one is right. Continuous data can be integer or not. Discrete data
Yeah,
can
yeah.
also. Let me give you an example. Suppose I want the name of the students who have marks in mathematics. Either the marks in mathematics will be say 25 or 27.5 or 28 or 29.5. So I'm making a set. I want the name of students who have marks either of these four, right? So I'm choosing the marks out of these four only. So this is the discrete data, either 25 or 27.5 or 28 or 29.5. Then I'm not choosing continuous. I'm choosing from a particular discrete value. These are some discrete data from which I'm choosing. And here you observe it can be fraction.
Yeah. Yes, sir.
Okay, so discrete means when you are choosing from a set. That will be better to understand.
Okay,
So I
sir.
have one
Thank you.
another question.
Let's continue.
So I have one another question related to the data. In the beginning of the presentation, you told that the data can be shared, but so every company declares or every company says that our search engine or our data is highly private
Okay.
and no one
That
can
is
share.
that is okay. That is ethical issue. But when you have joined Facebook now, during your joining, you have given the permission. So in those cases where data is available, we are talking about that data. But still, there is a huge amount of debate on the ethical aspect of using data. That is different aspect. When I am talking about data, here I am meaning the data which is shared by the person with their consent. Right?
Okay, sir. Thank you, sir.
Good morning, sir. My question is,
You are raising very, well,
if there is a picture of the person front of the person's name in the chat, then is this structured data? The images?
name,
হ্যাঁ, নেমের আগে যদি ছবিটা থাকে,
ছবিটা থাকে না, then it is unstructured data. You have to extract the name from picture and name. So you need to do some analysis. You need to use some technique to extract the name from the whole combination. That is generally regarded as unstructured data. I told you that you need to convert unstructured into structured. So you observe the example you are citing here. You are saying that the picture with a name, right? So that is the whole thing. This is unstructured. But when you want to get some information about that person, what you do, you take some particular tools, and what the tools does, it extract the name from that combination and place it in a table. Then it will be structured. Right?
So unstructured data are important.
Unstructured data,
Are they important?
of course,
Or-
important. Because as I've said, when you are searching for your pen drive, you are actually contributing to unstructured data. What the company does, that from they are extracting the information from that unstructured data. As I told you earlier, most of our data is unstructured. In our engineering cases, when you do some experiment, we get structured data. When you are writing some codes to simulate some data, that is structured data. But the data generally observed in social media is unstructured data. And most of our data is in that way.
Okay, sir.
Sir, our question about discrete data. Several times we see that discrete data is all about numbers, or it is anything like months, January, February, or
Right.
anything.
No, not
selecting
January, February. No. Please understand. Not January, February. The first thing, it should be digit, numbers. Numbers first. Because it is under numerical data. Right? So there will be some numbers. Then we can check whether that is a continuous type of number, or there is some particular set from which we can have to select it. Discrete data.
Sir, is there any machine or device to convert unstructured data into structured data?
Of course. We have several tools. You will learn.
Okay, sir.
It is not a one-day process. Of course, with time, we will learn. I'm just
Sir,
Sir, is data
in-
something that the user shares and information is something that the company is getting out of those data?
how the company getting the information or the data.
Sir, what is data and what
Whatever.
is information? Can you please explain again?
Data means, as I said earlier, data, it's layman language, data means anything. Your comments, your mail, your post, your likes, your dislikes, your emojis, your pictures, videos, anything can be data that can be stored digitally and that can be processed to extract some information out of it. That is data. And information means answer to some specific questions. And that answers are hidden within the data. From the raw data, when we extract some answers to some specific questions, that is information. Like whether
Okay,
you
sir. Thank you.
like a particular item or not. That's the question. To answer it, you require data.
sir, what is enterprise data?
What is
What's mentioned in structured data?
structured data?
Yes.
Structured data means anything, any data that can be fit in a tabular form, like this one. This is the structured data. The table you
No,
are
no, no.
observing.
I mean enterprise data. In your
Oh,
structured
that is
data slide,
That is different.
that
That is
is
different.
mentioned.
We will not discuss it today. Let's understand the basic thing today. Only the basic. Okay, now let's continue. There are so many to discuss. Now, whenever we have the structured data. That means whether you have the table, that means you have generated the data directly from your experiments in a structured way like this, or you have some unstructured data and somehow with the help of some tools, you have converted that unstructured data into some structured form like this. Now the next thing, why you are using the data? Because remember, our final objective is to get some information. Matlab, we want to have some answers to some specific questions. That is the intention. So first, I require data, either in structured or unstructured form, convert into structured form. Then I need to visualize the data. As for example, when this is in a tabular form, I can easily observe the data. I can check the data. Why I need to check? Because I need to check it so that if there is some missing question in the data, I can do some uh, methods on this because if the data is missing, that is of no use to me. Or if the data is wrong, I should observe it. As for example, suppose this data is collected from the Facebook account. Now suppose Jhinuk has not mentioned in that Facebook account her height. Her height is not mentioned. So this portion is blank suppose. I do not have the data. So this is an example of missing data. This portion is missing because Jhinuk has not shared it. So data is not available. So this is missing data. But all the other data related to Jhinuk is available. Only this one is missing. So I cannot get rid of the whole row because other portions are valid. Only this portion is not given. So I need to do something about this missing data. So first I need to observe whether some data are missing or not. This is one type. Or there may be something wrong with the data. As for example, suppose when the person who is collecting the data is say, instead of writing 174.5 centimeter as the height of Orithro, has written say 1745 centimeter. Definitely it is wrong. 1745 centimeter is not possible as the human height. So when I observe it, I understand there must be something wrong with this data. So visualization that's why it is so important. So once we visualize the data, I can observe whether there is some problem with the data, whether there are some missing thing in the data, whether there are some outliers in the data. Once I know them, then I can rectify them. It is called data cleaning. Trust me, in most of the data science related projects, maximum time is utilized in cleaning the data. 80%, 70 to 80% of the time is utilized for cleaning the data. So first, data cleaning is essential. Now here it is easy to observe the data because we have only 4 attributes starting from gender to height and only 4 people. Easy to observe. Instead, if suppose instead of 4 people, there are 100 people, then also you can observe it manually. But suppose there are 1 million person and number of attributes means gender, place of birth, date of birth, school, height, weight, etc. There are say 200 attributes. So think of the matrix. Now, what is say 1 million? 1 million rows and 200 columns. It's a huge amount of data. And in most of the actual data science, or not only in data science nowadays, in any data related project, whether it is automobile industry or electrical industry or computer science, when you are dealing with actual project, the data will be huge. And it is not humanly possible to observe the data manually. Then what can be done? There are some statistical methods, some mathematical tools you have with the help of which you can observe the data statistically. You can find out the mean of the data, median, mode, etc., by which you can roughly understand your data. But best way to observe data is to visualize the data, plotting the data. Suppose you have the height of person, you also have weight of the person. Now plot height versus weight and observe how it looks like. So visualization through graph is very, very important. And that's why each student, each engineering student, each respective of the stream should know about graphs. So this is called descriptive analysis. First, we need to observe the data and best way, as I said, through graphs. So once I know how my data is, next thing is to analyze the data. That means our objective is to extract some information out of the data. And again, there will be some mathematical tools depending on what type of analysis you want, whether you want to have some prediction, you want to have some categorization. Like as I said, in your email, you will observe there is a spam folder, and whether the mail is spam or not is automatically detected by the particular uh, email provider. Suppose Gmail, it is checking whether the incoming mail is spam or not. So there is some analysis going on in the behind, and that makes it make some categorization whether the mail is spam or not. This is one type of data analysis. On the other hand, suppose I want to predict what will be the marks of my students. If I know the history of the student in terms of marks, I want to predict what will be the next marks. I want to predict about the weather if I know the past data of the weather. So these are different types of analysis, and depending on what type of analysis you want to perform, you have different tools. And apart from mathematical tools, again, graphs will be very, very useful for analysis also. So graphs are essential for two reasons. One, for observing your data, and second, for analysis your data. And that's why I always give stress on understanding graphs. And that's why we have included graphs in proficiency module in SIP. Dr. Tanmoy Roy Chaudhary, probably on Wednesday, check the schedule. I will discuss about graphs, how the graphs can be drawn, what are the benefits of using graphs, how graphs can be used for prediction, regression analysis. That will be discussed. Even in your first year physics lab, all the experiments, the analysis portion will be based on regression analysis, so that you can refresh your memory of using regression. So understand the topic. It is very, very important for any engineer, irrespective of stream, as I've said earlier. Okay, let's. So I'm not going to discuss about graphs. So the point is, why we require this? Because when you are in a project, you are given a particular question. Like as I told when in our example, that as a restaurant owner, you want to know whether your restaurant is liked by the local people, right? So there's a question there, and to have the answer to the question, first you require the data. So next you need to write a report, and in the report, what you require, first thing you need to show the data. Second, how the data is gathered. Whether you have used some survey to get the data, or so whether the data is collected from surveys, whether the data is collected from some experiments, or by writing some codes by simulation method. So what is the method the data is collected? That should be mentioned. Then you need to show the data with the help of some graphs, and then how the analysis is done on the data, that must also be mentioned. And finally, the conclusion. So that is all about writing a report. Conclusion is very, very vital, because think when you are an engineer and in a project, working a project, and you are given a particular job, you have to submit a report. Now, do you think, and you understand that the report will be very, very huge, because everything will be in the report, starting from the data, how the data is collected, how the data looks like, how you analyze the data, to conclusion. That means your answer to the specific question. Now, do you think your CEO will have the time to read the whole document? No. The CEO mainly will observe some figures, pictures, graphs that you have given, and read the conclusion portion. And that's why conclusion is so important. So let's try to focus on the conclusion portion. Suppose I'm giving a simple question. Suppose your project, don't think that will be the type of question that will be asked in your BTech project. Suppose for your understanding, I'm giving it, say, suppose the question is, find out the volume of a iron bar by measuring its length, breadth, and thickness. You know the formula for measuring volume. So volume is length, breadth, and thickness. Once we know all these three, we can get the volume. So you have given different devices, like different types of scales are provided to you to measure the length, breadth, and thickness. And once you have measured them, you just multiply those three quantities, three numerical data to get, and that is numerical continuous data to get the value of volume. Suppose the volume comes out to be, say, 6.5123782217, etc. centimeter. Suppose this is the value. Oh, by the way, whenever you write values, data, numerical data, in most cases, there is a unit attached to that data. Do not forget, under any circumstance, do not forget writing the data with its unit. Without unit, there is no meaning of the data. Without unit, there is no meaning of the data. You must mention the unit. Say, if I ask what is your height and you say it is 170, what will I understand? 170 centimeter, 170 millimeter, 170 kilometer? I can choose any because you have not mentioned the unit. So data is nothing without unit. If there is no unit attached, like in case of ratios, there is no unit. That's different thing. But in most cases, there is some. So don't forget writing the unit. This is very essential. Okay, so this is our value. Now, if I use a normal calculator after decimal point, how many digits I can get? 8, 10, like this. If I use some programming language, say C, Python, R, MATLAB, etc., I can get number of digits from 8 to 32 after decimal places. Now tell me, will I write all the digits? Will I write all the digits in my conclusion? That is, here I have written so many digits. So should I write my conclusion as volume of that iron bar is 6.5123784217 centimeters cube? Tell me.
No, sir.
No, sir.
No. So what should I write? Or how should I write?
These are the rounded off. You have to find out the approximate value. The approx value.
Approx value. Up
Yes,
to which?
6.5.
6.5. Why not 6.51? Why not 6.51?
Sir, we will do countdown. Sir, at first we should take a round off, then we should take an approximate value.
Now my point is, I can write 6.5, I can write 6.51, I can write 6.512, etc. Point is, where should I truncate the data? Will I
that
truncate
should be
here
determined by the principle of
or
significant
here
figure.
or here? कहाँ पे truncate करना है?
Significant.
Significant digit.
The minimum.
How can I find out my significant digit? 6.5 पे क्यों? Why not 6.512 पे?
Sir, because we are doing countdown.
Sir, हम देख लेंगे अगर
डायरेक्ट राउंड ऑफ कर देंगे.
सर गाप ड्रॉ करने में सुविधा होगी.
कहाँ पे करना है? कहाँ पे? Point is, where should I truncate?
Data should be evaluated to such an approximate value so that it is easy to transfer this data into information for practical usage.
Now, point is, it will be most easy if I write it as 6 centimeter cube.
So we
But
should
will it
round
be
up to
accurate?
such.
So then it should be round up to 7, right?
Then it will round up and it will become 7.
7.
No.
Sir, we should round up to such a value that it matches the one of the value in the multiplication. Lowest value in the multiplication.
No.
Lowest
That's why
decimal
I'm
value in the
discussing.
multiplication.
No.
Yeah, I think we should round up to 6.6 centimeter cube.
No. So let's try to understand it. As someone has mentioned about significant digit, yes, we need to find the significant digit first. Depending on the particular problem, depending on the device that you are given, significant digit varies. And depending on the significant digit, your result will also vary. So before we answer this question, let's try to understand another easier question. Suppose this is a rod. You observe this is a rod. One end of the rod is attached to the zero of the scale, and you observe the other end of the rod attached to the scale. Tell me what is the length of the rod? Simple question. Tell me what is the length of the rod?
2.35 centimeter.
2.35.
2.35.
2.3. 2.3.
Hello.
2.3 centimeter.
2.35 centimeters, sir.
2.3 centimeter.
2.35 centimeter. Anything else?
2.2.
This will be 2.3 centimeters.
Sir, by rounding it to a plot value, it will be 2.
2.4 centimeter.
2.4 centimeter.
2.3, 2.4, 2.35. Anything else? Anything else?
2.35 centimeter.
2.35 centimeter.
2.35
I'm repeating. I was saying 2.3 centimeter, 2.35 centimeter, 2.4 centimeter. Is there anything else?
2.35 centimeter.
Anything else?
2.25 centimeter, sir.
No, sir, not anything else.
It is 2.3 plus minus 0.1 centimeter.
Again, repeat it.
I think, sir, it should be 2.3 plus minus 0.1 centimeter.
Very good. So first of all, you observe it is not 2.3 centimeter. It is larger than 2.3 centimeter, right? It is larger than 2.3 centimeter. As well as it is also not 2.4 centimeter. It is less than 2.4 centimeter. So I cannot say 2.3 centimeter. I cannot say 2.4 centimeter. And definitely I cannot say 2.35 centimeter. Eye estimation is not included in engineering. So either I have to say 2.3 centimeter or I have to say 2.4 centimeter. Better to say it is between 2.3 to 2.4 centimeter. The value of the length of the rod is in between 2.3 and 2.4 centimeter. Right? Now, why
Yes,
I
sir.
cannot say beyond it, but why I cannot say 2.35 centimeter? Because you observe the smallest value that can be measured with this scale is 0.1 centimeter. Between you observe between 1 and 2, between 1 and 2, there are 10 divisions. What is the length between 1 and 2? 1 centimeter. This is 1 centimeter. And this 1 centimeter is divided by 10 equal divisions. So 1 by 10 centimeter, that is 0.1 centimeter. That is the smallest value that can be measured with the help of this scale. Right? That is the smallest value that can be measured with this scale is 0.1 centimeter. And that we call as least count of the scale. So we call least count of the scale as 0.1 centimeter because that is the smallest value that can be measured with the scale. Keep it in your mind.
Excuse me, sir.
Least count means the smallest value that can be measured with the scale.
Excuse
And
me,
how
sir.
we have measured it? We observe between 1 centimeter and 2 centimeter. That is in between 1 centimeter. This length is 1 centimeter. There are 10 divisions. So value of one small division is 1 centimeter divided by 10. That is 0.1 centimeter. So that is the smallest value that can be measured. And that's why
1 millimeter.
Go beyond this. I cannot write 2.31. I cannot write 2.43 because the smallest value is 0.1 centimeters. Right? So that is the smallest value. Now that is called discount. Now, if you want to decrease the discount, what can be done? I'm not satisfied with this value. I do not prefer writing between 2.3 and 2.4 centimeter. I need to write it in a much better way, more precise value I should write. Then how can I do? Any idea?
Sir, we can use vernier caliper.
Earlier.
Vernier caliper.
Right.
Sir, vernier scale.
Because,
Sir, vernier caliper.
right. Why? Because if I want to, and there is another way. That way is that between, say, this is one, you observe, this is one, and what is this value? This is 1.1. So this is 1 centimeter, and this is 1.1 centimeter. And if I can write 10 equal division between 1 centimeter and 1.1 centimeter like this, observe here, between 1 and 1.1 centimeter, 10 equal divisions are drawn. That means now I can say what will be this length? This length is 0.1 centimeter. So 0.1 centimeter now divided by 10. So value, one smallest value would be 0.01 centimeter. So that will be the least count now. So least count can be decreased in this way. But this is a magnified image. What is the actual image? This is the actual image. So you observe between 1 and 1.1, with the help of subsequent instrument, I can draw 10 equal lines. But practically, would it be very useful for us? No. Practically, I cannot observe them. Those small lines in between 1 and 1.1 is of practically no use. That's why I cannot do this. And as we have mentioned, better to use vernier. And what is vernier? Vernier is at a scale. So this is your main scale. Again, you observe the same type of scale. Between 1 centimeter and 2 centimeter, there are 10 divisions. That means value of one smallest division is 0.1 centimeter again. Value of one smallest division is 0.1 centimeter again. But point is, when I attach the vernier, you observe this vernier has again 10 divisions. And zero, the first line, zeroth line of the vernier is aligned with the zero of the main scale. So these are completely aligned. So these portions are completely aligned. Now observe carefully. Let me magnify it. You observe 10th of the vernier. That last line, 10th of the vernier is coinciding with 9th of the main scale. 10th of the vernier is coinciding with 9th of the main scale. That means, can't we say, what is the length? Length is, this is the length. This is the length. This length is same. Now this length is measured by 9 main scales. This is the ninth. This is the ninth line. So ninth line of the main scale measure this length, and the same length is also measured by 10 verniers. So what 9 main scale measure, the same is measured by 10 verniers. So in other words, 10 vernier scale division, in short I am writing, 10 vernier scale division. What 10 vernier scale division measures, that is equivalent to 9 main scale division. Whatever length is measured by 10 vernier divisions, that same length is measured by 9 main scale divisions. So they are equivalent. That's why I can write 10 VSD equal to 9 MSD. 10 vernier scale division, what measure? The same quantity, same length is measured by 9 main scale divisions. So they are equivalent. Therefore, 1 VSD, simple arithmetic, is 9 by 10 MSD. That means what 1 VSD, vernier scale division measures, that is measured by 0.9 main scale divisions. 9 by 10 MSD. Right? So that is the equivalence between these two. This is the equivalence between two. And with the similar logic, I can say if 1 VSD is 0.9 MSD, then 2 VSD, 2 into 0.9 MSD, that is 1.8 MSD, and so on. But why we are doing it? What is our aim? Aim is to find out least count. Least count is measured in a very, very simple way. Least count is basically the separation between one MSD and one PSD. Just remember that. Least count means least count of what? Least count of this whole instrument. This whole instrument, that is main scale attached to a vernier, or vernier attached to this main scale. This whole setup. This setup has a least count of what? That I want to know. Because I know the least count of the main scale. That I know. That is 0.1 centimeter. Now I want to know what is the least count of the whole setup. That is vernier attached to the main scale. What is the least count? And that is equal to the difference between one MSD and one PSD. And how can we have the equivalence between the VSD and MSD? Simple. I'll check how many VSD are required to measure the length which will be required, and what is the requirement for number of main scale division. कितना vernier scale division चाहिए एक length के measurement के लिए, and कितना main scale division चाहिए to measure the same length. If I know that, then equivalence can be established like this. 10 VSD equal to 9 MSD here. And once I know it, I can find out the least count, because least count is 1 MSD minus 1 VSD. Then I can substitute VSD with the help of the equivalence and get the value of the least count. So this is the simplest process. If I want to reduce my least count, then this is the best process. So this is the process if I want to reduce the discount. Why I need to reduce the discount? Because I am not satisfied with this measurement. I want to reduce it so that my data can be more accurately predicted. So you observe, discount is somehow related to accuracy. If I can decrease the discount, accuracy will be improved. Matlab, instead of writing 2.3 centimeter, if I can write say 2.36 centimeter, it is better in terms of accuracy. I will say this one is more accurate than this one. So least count is always related to accuracy. Less the least count, better the accuracy. And that's why we have used, as we have also mentioned, a vernier. And this is the basic thing. Whenever we attach a vernier, then the least count is measured in this simple way. This is the separation between MSD and PSD. After today's session, I will send you a very small question set. My suggestion, try to solve those problems by yourself from our understanding of today's lecture. And if you cannot solve by yourself, I will be there to help. But first, try to solve by yourself. So let's understand it with the help of a particular example. So read it. What the question says: there's an instrument. That instrument has a linear scale with the value of one main scale division as 0.1 centimeter. You observe this is a question written in this way. From this question, I need to first extract some information about the data. Right? So let's do it. First, read it. So, an instrument has a linear scale. The smallest value of the linear scale is 0.1 centimeter. What does that mean? It means least count of the main scale is 0.1 centimeter. In other words, value of one main scale division is 0.1 centimeter. So this is one we know. One MSD is 0.1 centimeter. Just this is the previous question. And whatever we have discussed, I'm writing in the form of a question now. Now, also it says that the vernier attached to it has 10 divisions. The vernier has 10 divisions. That's previous question. The vernier you observe in the previous one, there are 10 verniers. Find out the least count. So what we have done, firstly, we know one MSD is 0.1 centimeter as per the question. Value of one smallest main scale division is 0.1 centimeter. So one MSD means I am writing it short. Main scale division 0.1 centimeter. And what is the equivalence? Equivalence is that there are 10 divisions, and we have observed that 10 divisions of the vernier must coincide with 9 main scale divisions. Observe the picture. 10th main scale coincide with 9th. Sorry, my mistake. 10th vernier coincide with 9th main scale. So equivalence is 10 VSD equals to 9 MSD. 10 VSD equals to 9 MSD. So that is known to us. So this is our extraction from this first portion. Now what we require, we want to find out least count, and we know that least count is just the difference between 1 MSD and 1 VSD. So first we need to find out what is the value of 1 MSD. Simple. Normal arithmetic, 1 MSD is 9 by 10. So 1 VSD is 9 by 10. MSD, that is 0.9 MSD. So least count as I have said, difference between 1 MSD and 1 VSD. 1 MSD, and we know 1 VSD means 0.9, that is 9 by 10 MSD. So 9 by 10 MSD. So the difference is 1 by 10 MSD. But still there is no unit. I am writing in terms of MSD. This is not the final value. I am writing in terms of MSD. But what is the 1 MSD? 1 MSD is 0.1 centimeter. 1 MSD is 0.1 centimeter. So if I put the value 1 by 10, and 1 MSD is 0.1 centimeter, so you get 0.01 centimeter. So least count of the whole device, that is vernier attached to the main scale, is 0.01 centimeter. So it is 0.01 centimeter, right? So it is 0.01 centimeter. So least count of the whole device is 0.01 centimeter. So you have observed, initially whenever we have used a normal scale only, then the length of the rod that can be measured was between 2.3 and 2.4 centimeter. Remember, we have said that it is either 2.3 or 2.4 centimeter, or better to say in between 2.3 and 2.4 centimeter. But now our least count is smaller. Matlab, I can write 2 digits after decimal. You observe, 2 digits. 2 digits after decimal I can write. So now I can write, say, the value is 2.37 centimeter. But I observe that actual length is larger than 2.3 centimeter and smaller than 2.38 centimeter. Now my length is in between 2.37 and 2.38 centimeter. So accuracy is improved. Previously I can write only 1 digit after decimal, but now I can write 2 digits after decimal. Of course accuracy is improved, but I may not be satisfied. I may require more accuracy. And how can I get more accuracy? By decreasing the least count more. If I can write more digits after decimal place, my answer will be more accurate. Right? So point is, if I want to increase my accuracy, I need to decrease the least count of the whole setup. And how can I decrease the least count? I can attach a vernier. A particular type of vernier if attached, then accuracy can be improved. Like here, I am using a vernier which has 10 divisions, and I have obtained the least count as 0.01 centimeter. Right? Now let's try another.
Excuse me, sir.
Let's try another. Yes.
Sir, can we directly use the formula of discount value of one main scale division divided by the total number of
Why? Yes, you can. But my point is, if I do not know how the formula comes, I always need to depend on the formula. I need to always memorize the formula, and memorization is not a good one. Try to understand. Because now if I change the question, your formula may not be useful now.
Yes, sir. Okay.
So better to know the process. Right? So now the question is slightly changed. You observe, I'm again writing that I'm using a same type of main scale. Why I'm saying same scale type of main scale? Because again main scale division is 0.1 centimeter. But now instead of 10 vernier division, now it has 20 vernier scale divisions. So previously, if this was my vernier, this is my length of the vernier, because I had 10 divisions. Right? Like this, I have 10 divisions. So this is the length of the vernier I have used before. Now I have given a better vernier. Better in the sense that it has now 20 divisions like this. So you understand, cost of making the verniers is increased, because previously it was a small vernier, now the length of the vernier is doubled. to accommodate 20 divisions, 10 more divisions are given. So I have changed the vernier. So what will be the least count of this device now?
Then sir,
Sir, the
What
answer
will be
is
the least count?
sir, answer is 0.055 centimeter.
Sir,
Yes,
11
sir,
by
that is the
200
answer.
centimeter.
Again, repeat.
0.02.
Sir,
Sir,
I
0.02
think
centimeter.
0.055 centimeter.
Sir,
Sir, 11 by 200 centimeter.
sir 0.005 centimeter.
0.00
5 centimeter.
0.05.
0.005 centimeter.
0.0.
Say 0.001 centimeter.
0.001. Okay.
Zero
First tell me. Okay, stop. First tell me what is the equivalence? Like in previous case, what was the equivalence? Equivalence
Sir,
was
20 vernier scale division is equals to 9 main scale divisions.
okay. Previously it was 20 VSD equals to 9 MSD. Now you are saying that 20 VSD, 20 vernier scale division is equivalent to 9 main scale division.
No.
Okay.
9
9
in
main scale.
MSD.
Okay. Let's check it first. Check it first. So 1 VSD equals to 9 by 20 MSD. Right? So what will be the least count? Least count is 1 MSD minus 1 VSD. So that means 1 minus 9 by 20 MSD. That is
7 by 20 also.
11 by 20 MSD. And what is 1 MSD? 0.1 centimeter. Calculate it and tell me the value.
Sir, 0.055. Yes, sir, 0.055 centimeter.
0.055.
Yes,
sir,
0.055.
So 55 centimeter.
0.055 centimeter.
What was the previous answer? 0.01 centimeter. Right? Previously it was 0.01 centimeter. So when you are using a small vernier, your discount was 0.01 centimeter. Now you are using a big vernier, large one, and your discount is 0.055 centimeter. Has it been improved?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Previously it was 0.01 centimeter. Now vernier discount is 0.055 centimeter. Which one is larger?
Sir,
This one, sir.
Previous one.
Yes, sir.
How your accuracy can be improved? By increasing discount or decreasing discount?
by decreasing
The decreasing list.
We always need to decrease discount. I need
But
to
depending
decrease. Decrease means previously it was 0.01 centimeter. That is after decimal I could write 2 digits. Now I am writing 0.055. So discount has been increased. Accuracy decreases. Whereas you observe I am using larger vernier and cost of the vernier is increased. So I am using more cost. I am spending more to reduce risk. Is it possible? Is it acceptable? I am increasing my cost to reduce the accuracy. So it's not possible. So
Yes,
point is the mistake is in the equivalence. So it is not possible that I cannot say 20 VSD is equivalent to 9 MSD. Forget about 9, forget about 10, 11. In fact, even if you use 18 MSD, 20 VSD is equivalent to 18 MSD, think logically. So if 20 VSD equivalent to 18 MSD, that means 10 VSD is equivalent to 9 MSD. Dekho, same as the previous case. 10 VSD equals to 9 MSD. That means
sir,
if I use
I have a problem.
Yeah, bolo.
Sir, I have a problem. Please, you can see this problem solving again.
I can see the problem solving. No?
I want to say that please you can see this solve again.
I cannot understand. Do I
Shadow
need to
আমার
repeat it?
বলতে বলছি
Okay. The point is previously our vernier has 10 divisions, right? So equivalence was 10 वर्नियर स्केल डिवीजन इज इक्विवेलेंट टू 9 मेन स्केल डिवीजन। तो जो भी लेंथ 10 वर्नियर मेजर कर सकता है वही लेंथ 9 मेन स्केल डिवीजन मेजर कर सकता है। दे आर इक्विवेलेंट। So 10 VSD equal to 9 MSD. Now I have increased the length of the vernier because the vernier has now 20 divisions. So जो काम 10 लोग कर सकता था, now I am employing 20 people. So my accuracy of the work should be improved because I am employing more people. Here I am using more verniers. Cost is increased. But if the equivalence is 20 VSD equivalent to 18 MSD, मतलब जो 20 वर्नियर स्केल डिवीजन कर सकता है, जो लेंथ मेजर कर सकता है, वही लेंथ 18 MSD मेन स्केल डिवीजन मेजर कर सकता है। If that is the equivalence, then it can be written as I'm dividing by 2 on both sides. So 10 VSD equal to 9 MSD. ये तो पहले ही हुआ था, 10 VSD equal to 9 MSD. So what has been improved by increasing the cost? मेरा cost increase हो गया because I am using larger vernier, but still I will get the same accuracy because ये तो वही आ गया 10 VSD is 9 MSD, same as before. So I have increased the cost because I have increased the number of verniers, but the accuracy I am getting is same. So up to this is not acceptable. So if I get this type of vernier, जहाँ पे 20 VSD को equivalent to 18 MSD or anything less than that, जैसे कि पहले तुम लोग बोला था 9 MSD, 20 VSD equals to 9 MSD, कोई भी वैल्यू 18 और उससे नीचे are not acceptable because they cannot improve the accuracy. Then what should be?
Sir, it should be 19 MSD.
So 19.
19. अब देखो
19
if
MSD.
20 VSD equivalent to 19 MSD, ये पूरी लॉजिकल सेंस से हो रहा है। 20 VSD, if it is 20 VSD equivalent to 19 MSD. Now do the process. So 1 VSD कितना होगा? 19 by 20 MSD. So least count कितना होगा? Least count is just the difference between 1 MSD and 1 VSD. So put the values. 1 VSD का मतलब 19 by 20. Put it. And so we get 1 by 20 MSD. अब 1 MSD का मतलब क्या है? 1 MSD मतलब 0.1 centimeter. Put it. Now you get 0.005. पहले क्या था? पहले डिस्काउंट था 0.01 सेंटीमीटर. Now डिस्काउंट कितना हो गया? 0.005 सेंटीमीटर. Discount decreases. So we observe previous discount was 0.01 centimeter. Now discount is decreased to 0.005 centimeter. Discount has मतलब accuracy improved. So
Yes, sir.
always remember, this is the tips. I have given so much time on this slide. Why? Because so that you understand that whenever you are using a vernier, if the machine, the device is not faulty, then the vernier should be like that, that if it has 10 divisions, then 10 division must coincide with 9 main scale. If the vernier has 20 divisions, then it must coincide with 19 main scale. If the vernier has 30 division, then it will coincide with
29.
29.
29 division.
29.
29.
29.
if it is 50, then it should coincide with
29.
49. Always remember,
49.
put it
49.
down.
Focus.
NVS is the general rule. Always coincide with N minus 1 MS. Always one less. Always one less. Otherwise, accuracy will not be. So remember it. So 10, 9, if it is 100 VSD, then it should coincide with 99 MSD. Simple. Simple. Right? So now we know this rule. So let's use it now. So now I am using better instrument, microscope. Some of you or most of you have used microscope in school. So these are microscope. And these are actually the portion of the microscope. You observe this is the linear scale. And I am zooming it. Observe it carefully. Observe between, this is 10. This is 10. You observe between 9 and 10. Between 9 and 10. Between 9 and 10, this is 10. between 9 and 10, there are 20 division in main scale. Now there are 20 main scale division. That means 1 centimeter is now divided by 20 main scale divisions. So previously, in all the examples, we have said main scale division, smallest value of main scale division, 1 MSD is 0.1 centimeter. You observe main scale division can also be improved, just like in the case of microscope. Here, main scale division is 0.05 centimeter. 1 centimeter divided by 20. So 0.05 centimeter. 0.05 centimeter it is now. Right? Now, there how many vernier are there? This is the vernier scale. Attached to it is the vernier scale. Can you tell me, just roughly, what do you think the number of vernier it has? What's the number of vernier?
11 units.
Hey, count the number. Lines. Count the lines. Just count the lines.
Sorry, sir.
यहाँ तक कितना है?
50. 6 lines.
Right. Total 50. So there are 50 vernier scale divisions here. So now observe. So the question is, there is a traveling microscope which has a linear scale with a value of 1 main scale division 0.05 centimeters. So previously discount of the main scale, that is 1 MSD was 0.1 centimeter. Now it is 0.05 centimeter. The vernier attached to it has 50 divisions. Find the discount of the microscope. Similar type of question, only the data has been changed. So what can we write for? What we can conclude from it? 1 MSD, what is the value of 1 MSD now? 0.05 centimeters. And what is the equivalence now? कितना main scale के साथ कितना vernier?
50 VSD is equals to 49.
50 VSD equals to
50
49.
VSD equals 49.
49.
1 less. N VSD equal to N minus 1 MSD. So if there are 50 vernier scale division, there must be 49 main scale division. Otherwise, accuracy cannot be. Right? So this is the equivalence. So let's just simply do it by yourself. Tell me the value of the discount.
0.001 centimeter.
Centimeter.
0.001 centimeter.
Right. Don't forget about mentioning centimeter. As I said earlier, repeating it again and again, I'm harping about the units because unit is very, very mandatory. Right. So discount again. What discount means? I'm writing it again. 1 MSD minus 1 VSD. So 1 MSD minus, now VSD means 49 by 50 MSD. So this is 1 minus 49 by 50. That's 1 by 50 MSD. Right. Value of 1 MSD is now 0.05 centimeter. So if I put them, I get the value as 0.001 centimeter. So you observe, right? So observe, initially our discount was 0.01 centimeter. Then we have improved it to 0.005 centimeter. Now we have improved it further as 0.001 centimeter. So accurately we can write now. So discount has been decreased, accuracy is improved. Right. Okay.
Yes,
so
sir.
this is why we should use discount. So this portion you actually know from your school days. I'm just revising this portion because I thought that you may have some problem in understanding. So now I think all the doubts are cleared. How you can measure discount, how discount can be improved, and by just checking the value, you understand how you can easily measure the discount. Right? Use the I will send you the problem set, solve it by yourself. Unless you solve by yourself, doubts will not be clear. Now, in school days also, whenever you hear the term errors, when you do some experiment in physics, say, you have to use the term errors. And by errors, you actually mean these 3 types of errors. When due to some negligence from our side, when we do some negligence by our side, then we have the human error. So human error can be avoided by using proper type of human being who are methodical, etc. Then random error, which are unavoidable, and to reduce random error, what we generally do, we take number of observations. Remember, when you have done some experiment in physics, instead of taking the one reading once, your teacher has told you to do it several times. Number of observations, increase the number of observations to reduce this random error. And that's why in engineering also, you never depend on a single set of readings. You will take a number of readings. Those who are related to computer science, you will observe, you will do simulation. You will write down a code to generate numbers, generate values, and again you will do it for a very, very large numbers to reduce this random error. Again, another type of errors, instrumental errors. If there is some faulty instrument, say you are using a slide calipers, which has some zero error, that is instrumental error. So if I replace the instrument with a better instrument, the instrument error can be avoided. So I am not talking about this type of errors. I am talking about that whenever you are using any device, that device itself has some limited accuracy. So it's not actually error. We prefer to say it as limited accuracy of the instrument. As for example, let me give you an example, what we have already discussed. When we use the normal scale whose discount was 0.1 centimeter. Then when we try to measure any length with that scale, discount was 0.1 centimeter. So whenever we use that scale to measure any length, how we can measure the length? We can measure it, say 2.3 centimeter or 2.4 centimeter, 2.5 centimeter, like this. Right? So I can write one digit after decimal point. And I am not satisfied. So what I do? I use vernier. When I use the vernier calipers, then discount of the device becomes 0.01 centimeter. That means I can write up to 2 decimal places. So now my value, the length of the rod will be now say 2.36 centimeter. Better result, more accurate result, but still I am not satisfied. So what I do? I use a microscope, a traveling microscope, and you have already found out the discount of that 0.001 centimeter. That means now with the help of that microscope, I can write say 2.364 centimeter. So you observe, accuracy is continuously increasing because discount is continuously decreasing. But I may not be still satisfied. I say that I am writing up to 3 digits only after decimal point. I am not satisfied. I want to write 5 digits after decimal point. So each and every instrument has some limited accuracy. No instrument is perfect. Remember it. No instrument is perfect. If you your assumption is that the instrument is perfect, I want to use that perfect instrument, then you are not doing engineering. So your devices, your instrument will never be perfect. Whether you are using an instrument in MCKVI or you are using the device from MIT, the instruments are never perfect. Each instrument has limited accuracy because always I can improve it. I may try to improve it. So suppose I am giving an instrument from MIT which can measure 2.36421 centimeter. That means 5 digits after decimal point. I may not be satisfied. No, I want to write 8 digits after decimal point. So that instrument has also some limited accuracy. So each device has some limited accuracy. So whenever you are writing your result, the accuracy may not depend on you. As I told you earlier, I'm not talking about human error. I'm not talking about faulty instrument. I'm not talking about random error. If everything is right, I'm giving a not faulty instrument, the human is perfect, I'm doing a number of readings, still my result may not match with the result of other person. Why? Because the 2% may use two different instruments. Say I am measuring the length by a normal scale. So what my result will be? I will say my length is 2.3. I'll say my length is 2.3 centimeter. On the other hand, when my result is verified by you, you are checking my result, and you have a subsequent instrument. Suppose you have a traveling microscope. So when you do the same, you will get result as 2.364 centimeter. You will get the result as 2.364 centimeter. So you will say your result is wrong. Viju, your result is not correct. You will say me. But is it? Is it my fault that my result is 2.3 centimeter? Is it my fault that I cannot write more digit beyond 3? No. It is due to the device and the limited accuracy of the device that is given to me. Whatever device I am using, whatever scale I am using to measure the length, the accuracy depends on it. So don't blame on your result. It may be due to the limited accuracy of the device, the scale you are using. So how can you show it in your result? That I am writing 2.3 centimeter because I am giving a scale whose least count is 0.1 centimeter. One student initially mentioned it. That is the way to write it as not the length only, but length plus minus that limited accuracy. In some people call it as error also. That's why I am also saying it error. But as I say, it is not the error actually. It is the limited accuracy of the device, which is nothing but least count. So I should not write only L centimeter, 2.3 centimeter. I should mention as L plus minus the error. That means the least count. So I should write as 2.3 plus minus 0.1 centimeter. That I should write. That means instead of I'm giving a message here, actually two messages I'm giving here. First thing, I am saying that I am writing 2.3, one digit after decimal place, because my device has a discount of 0.1 centimeter. I cannot go beyond it. So this is the first point I am mentioning in my conclusion. Second thing, I am not giving a value. I am not giving a value. Rather, I am supplying a range. You observe, I am actually giving a range, 2.2 to 2.4 centimeter. I am saying the length of the rod lies in between 2.4 and 2.2 and 2.4 centimeter. I am saying the length of the rod is in between 2.2 and 2.4 centimeter. So I am specifying a range instead of a value. So if anyone else has measured it as 2.364 centimeter, you observe this value is within my range. This value is within my range. So my answer cannot be regarded as wrong answer now. That's why this is the way of writing a value. The value plus minus the error. Error means least count of the instrument. Least count of the instrument. So in the second case, in this case, how should I write? I should write the answer as 2.364 plus minus. What is the discount of the device? 0, 0, 1. So I should write the answer as this. So again, I am meaning that I am using a device which is more accurate, whose discount is 0.001 centimeter. And what is the range I am specifying now? 2.363 to 2.365 centimeter. This is the range I am specifying. You observe, this range is much closer range. The previous one, this one, this was a broad range, 2.2 to 2.4 centimeter. But now, a narrow range I provide. Very narrow range, 2.363 to 2.365 centimeter. But still, there is a range. Still, there is a range. Because as I've said, no device, no scale is perfect. We always have error. We always have limited accuracy of the instrument. Right? So this is the way we can always write our answer. But problem is not solved. What was the problem? Think I was specifying a very, very easy problem. And from that, we are discussing so many things. What is the problem? Find out the volume of the iron bar by measuring its length, breadth, and thickness. So this is the way I can measure only length, or only breadth, or only thickness. Right? not the volume. Not the volume. Why now the problem is still remains? Because volume means length into breadth into thickness, right? So suppose length is measured by a normal scale. That is, least count is 0.1 centimeter. Breadth is measured by slide caliper, say whose least count is 0.01 centimeter. Thickness is measured by a traveling microscope, whose least count is 0.001 centimeter. So you are using three different devices to measure the three quantities. Three different devices to measure three different quantities. Right? Right? Now, if the volume, suppose the volume is calculated as 6.237578, etc. centimeter cube. So we'll talk about truncation. But point is, इसके साथ एक plus minus add करना पड़ेगा. You need to add the least count with it. But now the problem is, whose least count will you consider? Because you are using three different devices. You are using three different devices to measure the three quantities. Different least counts you have. So whose least count will you consider now? Answer it. किसका least count use करोगे?
So
You have defined device.
Traveling microscope.
Traveling
So
Traveling
microscope.
It's a traveling microscope.
Traveling microscope. Why?
Traveling microscope.
Why? Why traveling
Because it
microscope?
has the most accuracy.
It has the most accuracy. But
Least count is
okay, I get your point. But point is, length is also measured. When you try to measure volume, length is measured also, and length is measured in a less accurate device. Then how can I say the total least count should be 0.001 centimeter?
Sir, in this case, shall we have to multiply all the least counts of the instruments that we use to?
No.
Sir,
Sir, I
So-
think we should take an average value of the least count.
No, so not average, not addition, not multiplication, not taking the best, not taking the worst.
Yes, sir, I think then we
Suppose-
should use the same device for all these cases.
No,
Height,
some cases we have to use different device.
then it's create a problem.
Create a problem.
Yes.
So what is the solution?
So we can take
Yes.
the first 2 decimal point of same as 1 year calipers and take the other ones so that we can
Good thinking, but not the right one.
Sir, we
Let me take
greater less count.
No. I told you, not the best, not the worst, not the sum, not the multiplication, not the average.
just
Neither.
leave it. You should leave it.
No, we'll do it. Before that, let me tell you another concept. The concept of relative error. Relative error means what is the error divided by the value. Suppose you have measured the value as 2.3 centimeter. This is the value you have measured, and the error, that is least count, is 0.1 centimeter. So error or least count by value, that is called relative error. Suppose you are using microscope, so your error is 0.001 centimeter. The value is 2.364 centimeter. So that is relative error. And relative error is generally written in percent. So delta L by L into 100%, like this. Now, why relative error is important? I'm giving an example. Suppose you are measuring two quantities, length and breadth of a device, using the same scale. You are talking about using the same scale now? Therefore, what happens? If you are using the same scale to measure both length and breadth. Now, observe, length is 100 centimeter, length is measured as 100 centimeter, breadth is measured as 1 centimeter. Right? Length is measured as 100 centimeter. By the way, observe one thing. I have not written 100 centimeter. I have written 100.0 centimeter. Please note, 100 centimeter and 100.0 centimeter are not same, or 100.00 centimeter are not same.
So when
Why? Because if I write 100 centimeter, then the next digit that can be measured is 101 centimeter. What I am saying is that if the length and breadth both are measured with the same scale, whose least count is 0.1 centimeter, absolute error is same in both cases. In the first one, oh, by the way, I was talking about this. 100 centimeter means the next length will be 101 centimeter. If I write 100.0 centimeter, means next value that can be measured is 100.1 centimeter. If I write 100.00 centimeter, means the next value that can be measured is 100.01 centimeter. So everything has meaning. So coming back, so in the first case, it is 100.0 plus minus 0.1 centimeter. That's you will write. In the second case, you will write 1.0 plus minus 0.1 centimeter. देखो दोनों का ही absolute error is same 0.1 centimeter. दोनों का ही. But do you think that measuring 100 centimeter 0.1 centimeter error is very large? Does it contribute to a very larger amount of error? 0.1 centimeter with respect to 100. Think of it. Whereas in second case, 0.1 centimeter with respect to 1 centimeter. In case of previous, 0.1 centimeter with respect to 100. I can neglect that. I can neglect 0.1 centimeter with respect to 100 centimeter. On the other hand, it is very difficult for me to neglect 0.1 centimeter with respect to 1 centimeter. And that's where relative error comes in. Now, in the first case, relative error, that is delta L by L, will be 0.1 by 100. What will be the value? 0.001, right? That means kitna percent? That is, what will be the value in percentage? It is 0.1%, right? So measurement error is only 0.1%. Matlab, in 100, only 0.1% is the error. Whereas in the second case, it is 0.1 by 1. So relative error is 0.1. That is 10%. You observe. You are doing an experiment. You are getting some result, and within the result, 10% is error. Is it an acceptable result?
No.
Whereas in the right. That's why we always trust on relative error, because relative error tells us whether our error is important or not, whether I can neglect that error or not. That's where it is important. I'll quickly summarize. Time is running out. So this is the concept of error. And now coming back to our question quickly. So I'm first doing it in general case. So say instead of volume, I want to measure Z. And Z depends on 4 quantities, A, B, X, and Y. If I know all these 4 quantities, A, B, X, and Y, then I can find out the value of the Z. So I know Z, I will know Z only when I know A, B, X, and Y. If I know the value of A, B, X, and Y, I put them in that formula and get the result. Right? Like in case of volume, if I know length, breadth, and thickness, I put the values in the formula and get the result. Right? Now, out of these 4, A and B are constants, and X and Y are variables. Note it down. Please understand very, very carefully. Whenever you hear the term constant, I know that in your mind, what counts is universal constant, like velocity of light in free space, Planck's constant, Boltzmann constant, gravitational constant, This comes into your mind. But please understand, anything can be constant if you're not measuring it. Like length. Length is generally not a constant. But suppose you are not measuring the length. Suppose you want to find out the volume of a rod and I have supplied the length to you. You are not measuring the length. Understand it. You are not measuring the length. Length is supplied by me. So you will treat length as constant. So you will treat length as constant. So what is constant? Constant is anything that you are not measuring. Simple. Anything that you are not measuring will be treated as constant to you. You are measuring x and y, so x and y will be your variable. A and B are supplied. You are not measuring them. So they will be treated as constant, right? Now, what I want to find out relative error in Z. I can find out error in x and y easily. I check whatever the device I am using. Suppose x is length. I am using a normal scale to measure length. So what I will do, I know the error in measurement of length will be the least count of the device. It is the least count of the device. So it is 0.1 centimeter. I know it. But how do I know what would be the error in measurement of Z? How do I know what will be the error in measurement of Z? That is the important thing. That I want to know. Please understand. Remember, if I want to, in the previous case, what was the question? I want to write down the answer volume. I want to write down the answer of the question. What is the volume of the iron ball? That I want to know. Okay. So, what I should write? I should write it in this way: volume plus minus the error. And what is error? Error delta V is the absolute error in measurement of V. But I do not know what is the value of delta V because we have used different devices to measure V, the portion of V. That's why I do not know this delta V. That is the problem. So that I want to solve. So here also I want to find out Z. So what I should write as I want to write as Z plus minus delta Z. That I want to know. So delta Z is not known to me. I want to find out this delta Z. So that is the technique I am telling you. So what you will do, if you know the formula, first thing what you will do, take log on both sides. Natural log. Take log on both sides. That is, I want log Z on this side also log a b cube x square y. Right? Take log on both sides. Now you know why I'm using log, because if I use log converts multiplication in addition. So if I take log on both sides, this will that will happen. So if I take log on both sides, multiplication will be written as addition. So it will be log of a b cube plus log of x square plus log of y. Why I'm writing a b cube in this way? Because all the constants I'm putting in one side. All the constants I'm putting in one side. So this is total constant. So log of constant plus log of x square plus log of y. Any doubt? Log always converts multiplication into. We also know log can convert powers into multiplication.
Yes, sir.
We have a power here, x square. So power will be converted into multiplication. Power will be converted into multiplication. Right? So we can write it in this way. Log of constant plus 2 log of x plus log of y. Multiplication, power comes into multiplication. Done. So why we have used log? So that our equation becomes much simpler form. There is no power now, there is no product now. In this way. Now what we'll do, I will take differentiation on both sides. What is the differentiation of log? Differentiation of log z means 1 by z dz. Now instead of dz, I am using the term delta z here. You can also use d capital this term delta also, same thing. Why this symbol instead of d? Because z depends on x and y. There are two variables, more than one variables. So partial differentiation. That's why I'm using delta symbol instead of D. So if I take differentiation on both sides, left hand side will be delta Z by Z. Left hand side will be delta Z by Z because log differentiation of log is 1 by something. So 1 by Z, delta Z. Differentiation of a constant. What is the value of differentiation of a constant?
Zero.
Zero.
That's why you understand. That is why I have taken all the constant in one place. Because ultimately it will be zero. It will not contribute. Now 2 comes log of x differentiation karo, so delta x by x. Next log of y differentiate karo, delta y by y. So simple. This is my final value. And now we have the result. Trust me, we have the result. So what we have done, I am using the formula, take log on both sides, then simply differentiate. And I get the result. How am I getting the result? Observe. You have measured xy, so you know the value. Suppose length is 2.6 centimeter, you have measured by normal scale. So x is known. Suppose y is the breadth. You have measured it with a traveling microscope. So its value is say 0.129 centimeter. You know the value. What is delta x, delta y? The least count of the devices that have been used. So if you are using a normal scale, so delta x will be 0.1 centimeter. Delta y, you are using a traveling microscope, so delta y will be 0.001 centimeter. So all the values on right hand side are known. X, y are the variables that you are measuring. Like in case of now think in case of length, breadth, thickness. Volume equals to length into breadth into thickness. So what will be the formula in this case? In this case, the formula will be delta V by V equal to delta L by L plus delta V by V plus delta D by D. Now LBD, length, breadth and thickness, you are measuring from the devices. Delta L, delta B, delta D are the least count of the devices that you are using. So if you are using normal scale to measure length, so delta L will be 0.1 centimeter. Delta B, you are using slide caliper, so it will be 0.001 centimeter. You are using traveling microscope to measure depth or thickness, so it will be delta D will be 0.001 centimeter. So all these quantities you know. So if I put them, I get delta V by V. Similarly, in the example given in this slide, delta Z by Z is twice delta X by X plus delta Y by Y. Now I have measured X and Y by two devices, so I know the discount of those devices. I put the values as delta X and delta Y. So when I get all these values, I get delta Z by Z. Right? So once I know delta Z by Z, once I know delta Z by Z, then I can calculate. Once I know the value of delta Z by Z, then I can find out the value of delta Z also. So delta Z will be delta Z by Z into Z. How we know Z? Because I know I have the formula. I have the formula. So I can easily calculate Z with the help of the formula. So Z I know, delta Z I know, delta Z by Z I know, so I know delta Z also. And once I know delta Z, I can easily write now Z plus minus Z. So this is the way. This is the way you should measure delta Z. I'm giving another example. Simple. Just I have changed the formula. You observe, now I have written Z as A B Q X squared by Y. Right? So similar process. First I will do log on both sides. So log on both sides. Only Y will be minus log Y because division is converted into subtraction.
Yes, sir.
Then power is converted into multiplication like this. So this is my log Z. Then what I will do? I will take the differentiation on partially on both sides. So left hand side delta Z by Z. Right hand side this will be 0. So twice delta X by X minus this minus delta Y by Y. Okay. So this is my formula now. Delta Z by Z is this. Mathematically correct. Physically is it correct? Let's understand it quickly. What is X and Y are the variables, that quantity you are measuring, like length, breadth, thickness. Delta X, delta Y are the quantities, that is the errors, the discount of the devices, discount of the scales, discount of the devices that you are using. What is delta X by X? Delta X by X is the relative error in measurement of X. Matlab, whenever you are trying to measure X, due to limited accuracy of the device, you are getting some error. And that relative error is delta X by X. जैसे मैंने बोला था, each device has some limited accuracy. No device is perfect. So whenever you are trying to measure, you are getting some error. So whenever you are trying to measure Y also, you are getting some error due to limited accuracy of the device. And the relative error is delta Y by Y. So delta Y by Y is the relative error. That means whenever you try to measure Y, whenever you are trying to measure Y, there will be some error due to limited accuracy of the instrument. There will be some error due to limited accuracy of the instrument. So we have some error due to measurement of X. No, we will have some error whenever we are trying to measure Y. So whenever we are trying to measure anything, there will be some error. So error is always additive. So though this formula is mathematically correct, but I convert it as this. I'll always convert the negative into positive because errors are additive. All errors are contributing to the total error. जब भी तुम x को मेजर कर रहे हो, कुछ एरर तुम्हें मिल रहा है, y को मेजर कर रहे हो, y से भी कुछ एरर मिल रहा है. So you always adding these errors. So that will be the formula. So this you always remember that errors are always added. This slide I am not showing the same thing. Only instead of using log, I can directly take partial differentiation. Now, coming back to the final one. Suppose our measured quantity is Z equals to, this is the formula. So if I put all the values in the formula, I get the result as this. This is the result I am getting. So Z equals to this whole thing. And what was the problem that I started with? That where to truncate? Should I truncate is at 4.2 or 4.323 or 4.234? Where? Now this is the time to answer it. After doing so much thing, of so much discussion on error. So first thing, when we know the formula, I'll easily calculate the relative error. Like here, the relative error is delta Z by Z will be twice delta X by X plus delta Y by Y. This is the way error formula. And when I put the values of X, Y, delta X, delta Y, when I put the formula, I put the values in the formula, I get some result. Suppose the value is this. When I put the value of X, Y, delta X, delta Y in the formula, I get this result. So this is delta Z by Z. What I require, remember what I require only delta Z, the absolute error. Absolute error in measurement of X, Z. That means whenever I try to measure the whole Z, when I want to measure volume, what is the absolute error in measurement of volume? That I want to. That you are saying that whether it will be average of all the discount or it will be the mean of discount or max of discount, etc. etc. So now we are trying to answer. So I want delta Z. So how we can get delta Z? Simple. Delta Z means Z. This is this Z into delta Z by Z. We have calculated both. We have estimated Z by simple formula and the relative errors. We just multiply these two and get some value. Done. Done. Delta Z we now get. So we now know both Z and delta Z. Now we know both Z and delta Z. So how we should write the final answer? Z plus minus delta Z. That means, suppose I am writing it here. Say 4.2341689 and delta Z 0.00137994, etc. There are some other digits also, no problem. Now if I add these two, because you know Z plus minus delta Z, I can add delta Z to Z or I can subtract delta Z from Z. But the addition is easier, so I'm doing the addition. So if I add them, first 4 plus 0, no change. No change in the value. So 4 plus 0, 4. Same. Next 2 plus 0. Attention please. 2 plus 0, 2. No change in the value. Next 3 plus 0. Again no change in the value. Now 4 plus 1. Value changes. So all digits after this will change. So from this digit onward, from the third decimal place, you observe from the third decimal place, value starts changing. Before that, there is no change in the value. 4.23, it was 4.23. But third decimal point was 4, now it is 5. If I do subtraction, then it will be 3. So value changes from the third decimal place. I will truncate my data at that place. So point is, where will I truncate? Answer is, I will truncate from where the value changes. I am repeating. I truncate my data at that point from where the value changes. So value कहाँ से change हो रहा है? Yes. So I truncate my data at third decimal place. जहाँ से start हो रहा है, वहीं पे truncate करना है. So my answer should be written as 4.234 3 decimal place because वहीं पे truncate किया. Similarly, error को भी वहीं पे truncate करना है. So 001. This is my result. Whatever unit it has. So that should be the result. Now, I also know. So देखो, again we have given a range, not a single value. I have given a range. Instead of 4.234, I am saying 2.234 plus minus 0.001. So I am saying giving a range. Range is 4.233 to 4.235 unit. That is the range I am specifying now. The point is, I also know that this value, the third decimal place, 4 digit, the digit I have written 4, that is not also correct. That changes. Observe here. Observe here. The third decimal place is not correct. It also changes. To identify it, I am giving a bar symbol. Bar symbolize that this value, this digit is also not correct. So all values from this digit onward are not correct. But I am keeping up to this. So I am truncating here. So that is where we should truncate. So how we will find out where to truncate? First, find out what is the error or limited accuracy for each instrument, that is least count. Then you check the formula of the quantity you want to measure, like here Z is this. Find out the relative error, then find out the absolute error. Once you have the absolute error, then check from where you need to truncate it. Quickly. Suppose measured quantity is this. Relative error is this. Tell me where should I truncate? Quickly tell me.
At 8.
8 sir.
कहाँ पे truncate करना है? कैसे
Sir,
करोगे?
8. 7.76.
Sir, at
Be
6.
careful. Be
7.76.
careful. What I told you, if I want to find out this, first thing I need delta Z, not delta Z by Z. First find delta Z. First find delta Z. If I find delta Z comes out to be this. Now tell me, what should I
At
truncate?
3.
Sir, at 6.
कहाँ पे? कौन सा
Sir, after second
Sir,
decimal.
7.73.
And 6.
Because if I
At
add
6.
these two, Z and delta Z, first digit remains unchanged. 7 remains unchanged. उसके बाद point है next digit after decimal 7 remains
Sir,
unchanged. Next 6. Now it changes.
6 changes.
I'll truncate here.
6 and
I'll truncate.
at 6, sir.
I'll truncate here. 7, 6. So our final answer should be 7.76 plus minus 0.0. And 6 के ऊपर एक bar symbol दे देना. To symbolize that this 6, this digit 6 is also not correct. ये भी सही नहीं है, क्योंकि ये भी change होगा. But I can keep it. So this is my final answer. So now you know how to handle when So you are not directly measuring the quantity. Like volume, you are not measuring volume directly. You are measuring main grade thickness. Then you can calculate that of the quantity. Then absolute error will be measured in this, and then only you can truncate the data. And one simple tip: in some cases, in your value, suppose you are measuring y. Y is the quantity. Do it matter of Young's modulus. It has a formula. When you put the values in the formula, you get the result like this. You observe there is a huge number here, 10 to the 11. And the relative error you have estimated is this. This is the relative error you have estimated. Okay, this is the relative error you have estimated. Delta y by y is this. So first thing, I require delta y. And how can I find out delta y? Simple. Delta y by y into y. Both are known to me. Now, when you do this is the trick. Trick is when you do this, whenever there is a power, like here, there is a power, do not utilize the power. मतलब कैसे करोगे? This is how. When you put the values, y is this, delta y is this, you are putting the values. Then when you do the calculation, keep the power thing unused. Power को multiplication में मत लो, उसको रख दो. तो multiplication करोगे ये दोनों के बीच. जो भी रेस्ट जो भी है उसको मल्टीप्लाई करो. पावर को मल्टीप्लाई में मत घुसाओ. So power is left aside. So if I keep the power aside, what is the value? This will be the value. Why? Because now after estimating delta y, what you need to do? You need to add it with y or subtract it from y, right? And if they have same power, isn't it better to handle it? दोनों का ही power same है. Suppose if I ask you, tell me the addition quickly. One is 5.239 into 10 to the power 11. Another is 0.024 into 10 to the power 8. Can you do it quickly? If I just ask you to add this two?
No, sir.
If I ask
हमें पहले power को adjust करना होगा.
दोनों का ही power same है अब. It will be easier to handle. That's why I am telling you, whenever there is a power, do not use the power in the calculation of delta. Y, delta Z, whatever you say. The absolute error measurement. Keep it aside like this. It will be easier for calculation also. Then next thing, you just check what to truncate. Because दोनों का ही power same है. Tell me what to truncate. So tell me what will be the final result. Tell me what will be the final result.
12.73.
Final result
12.73 10 to the power
73.
So yes. Why? Because
12.73
plus minus from second digit onward value changes. Right. From the second digit onward the value changes. Therefore, we'll truncate here. We'll truncate. So it will be 12.73 plus minus 0.01 and 10 to the 11 always kept. So
Yes,
you
sir.
will just write it in. So that will be our final result. Simple. So that is all about data, how to extract information from the data, and we have used some practical aspects of that through measurement quantities. Like we have checked how to find out relative errors, how to check what will be the significant digits, and how to write down the conclusion in a report. Most important thing. Now I am reminding you again, I will send you the questionnaire, a very small set, 4 or 5 questions will be given there. Answer it by yourself. Any query?
Sir, I want to request, sir, can we get the PDF version of the session?
Okay, I'll send it to PDF of this slide. So
Yes, sir. Thank you,
Okay,
sir.
I'll send it.
So do we need to submit those answers? So the questions that you will be sending, do we need to submit those answers of this question?
I'll send you the this slide and the questionnaire through email. Try to answer, try to solve those questions by yourself. If you cannot do, from the next week you are coming to college, I will help you there. Yes, I will send you the answer also. Solution.
Okay, sir.
Thank you, sir. Okay, sir. Okay, sir. Okay, sir.
Thank you.
Okay, sir.
Thank you.
Check your schedule. Probably
Thank you,
from
sir.
Thank you, sir.
your next class will start.
Thank you, sir.
Thank you, sir, for your wonderful
I'm stopping my share.
Sir, thank you so much,
So you
sir.
must rejoin at the scheduled time.
Thank you, sir.
Thank you, sir.